Hey everybody, today we're going to knock out the first lesson in parallel and perpendicular lines. We're talking about how lines, and in this case even planes sometimes, fit together as being parallel or perpendicular and what that really means. This is going to be a little bit different than an algebra lesson about parallel and perpendicular, because in algebra you're learning about what you can do to calculate ways that these could be proven to be parallel or perpendicular. We'll get to that later, but right now we're just talking about what these look like and how to identify them. So we'll just get started and jump right in. It shouldn't be too long of a lesson today. We're going to start with the definition of parallel lines, and the symbol is just going to be two vertical lines like that. Nothing that shocking. When two lines are parallel, they never touch. I cannot emphasize that enough. No matter how far they go forward, they never touch. There is one little technicality, though. They have to be on the same plane for it to count. So again, you got two lines, and as they move along, they never, ever touch. Those would be parallel lines. They have to be on the same plane for it to count. So that's the picture I'm going to go with. And they have to be on the same plane. Now, a lot of times, in order to designate on a picture the two lines are parallel, we will just put one extra little arrow there. And then since these two lines have the same marking, looks kind of like an arrow, like I said, that means they are parallel. All right. So we got that going for us. Sometimes you'll have a picture with multiple sets of parallel lines. So maybe you'll see a picture where there will be lines marked with two arrows. Okay, so then those two would be parallel instead. So they have to match. The symbols have to match. All right, quick note here. Two planes can also be parallel. They must never touch. So I want you to just think of that like just a box. Like if you're just dealing with just a standard boring box, nothing that exciting here. And then you just sort of imagine the top of the box, and then you imagine the bottom of the box. There you go. Yeah, it looks pretty good. It was not perfect, but that looks pretty good. If you think about the way a box looks, I think it makes more sense when you just sort of visualize what's going on. The top of a box and the bottom of a box are parallel planes. That's sort of how we can visualize it. Obviously, in real life, planes go on forever and boxes don't, but it can still help us get a good sense of what's going on. Or maybe you could think of it as the left side of the box and the right side of the box. Or maybe the front and back. Those are all good examples. All right. Let's go to perpendicular lines. The symbol for perpendicular looks like this. So you got kind of the upside down T going here. When two lines are perpendicular, they cross at an exact 90-degree angle or a right angle. Now, this is kind of a weird sentence, but I just want you to visualize what's going on. They don't always look like they are on the same plane. Here, let me capitalize that. I put it in capitals on the notes because I think people don't always understand what's going on. Let's say we have a plane here. Let's say we just draw out a plane. Okay, so you got this, you got this, you got this, and you got this. So we'll just think of this as a regular plane. Now I want you to think of the idea of maybe taking a pencil, for example, and just taking a pencil and sticking it directly in the middle of the plane. So we're just going to take a line here. Like I said, I'm just thinking of like a pencil through a sheet of paper, but basically like a line. And you take that line and you stick it directly through that plane. So obviously it doesn't look like the line is on the plane, and it's not, but it is still perpendicular to the plane. it is still making a right angle with the plane, vertically speaking. So again, that's sort of a weird thing to visualize, so we just sort of do the best we can. Speaking of weird things to visualize, let's put skew lines in here. There is no symbol for these. They are just messed up. They are not on the same plane, and they don't touch. So, when we think parallel lines, we think lines that don't touch. But what if they're not even on the same plane? So not only are they not touching, they're not even on the same plane. They are just completely out there in outer space. Those would be skew lines. So again, if you took one line, and let's say you had a line that you drew on the front of a box. So let's say like this. So you have this line, and you draw it on the front of the box. And then you had a second line that you drew maybe on the right side of the box. Right here, let's say. They never touch. They're just sort of out there in outer space. Those would be an example of skew lines. Okay, so it's kind of a weird thing. Again, it's kind of hard to visualize, but you'll get better as you go. All right, now let's get to one of the most important things that we're going to talk about over the course of the next few weeks, lines being cut by a transversal. So that's what we're going to do here. We're going to talk about a transversal. And I'll be completely honest, when I put this next line in here, it was mostly just so that you would have to write the word twice. A transversal is the official name for the line that cuts through two other lines. Okay, so you got two lines. So I'm thinking of this line and this line, and they are both being cut by a transversal. That's what that third line is. When this situation takes place, I think the most helpful thing to do is to look at it as 8 different angles. Okay, so I actually want you to write in the numbers 1, 2, 3, 4, 5, 6, 7, 8. Because I think that's the best way to help us understand just what I'm talking about here. All right. Now, there are a ton of different relationships that pop up in this picture here. And the first name of it, the first name that we use is corresponding angles. So what happens when you have two lines being cut by a transversal and the angles that we're talking about match up? That would be like upper left, upper left. So for instance, 1 and 5 are both in the upper left of their corner. Okay, so in this case, 1 and 5 would be corresponding. You can use the exact same concept to list off even more. So 1 and 5, 2 and 6, 3 and 7, 4 and 8. That would be a great example of corresponding angles. All right, now we've got a few more here that we do. And the next one, there are 2 different names. I have seen it written 2 different ways, so I'm going to give you both so that you don't have any excuses later on when you do your work. Same side interior would be the next one. Now, we are not very creative sometimes when we get our math textbooks. People are not very creative. The same side interior angles would be the ones that are inside the 2 lines and on the same side. Wow. So in this particular picture, when I think same side and interior, so you have to be in the interior of the picture and you have to be on the same side. So that would be like 3 and 5. Or the other option would be 4 and 6. Okay, so 3 and 5, 4 and 6, those would all work. Now, I told you I was going to warn you about another way of saying it here. So really quick, sometimes same side interior angles are called consecutive interior angles because as you go down the line, they meet consecutively. So you got 3, and then you just keep going down the line, and there's 5 in order. You know, if a basketball team wins consecutive championships, it means they win 2 in a row. So that's what it means. So consecutive interior, that's another name for it. You will see it that way sometimes. All right. So the next one, we're still talking about inside the 2 lines, but now they are on different sides. They are on alternating sides. You've got one on the left, one on the right. So what do you know? Alternate interior. Again, sometimes we are not very creative, and that's okay. So in this case, now you still want to be in the interior of the picture, but this time you want to be alternating sides. So now 3 would go with 6, and 4 would go with 5. Okay, so we'll just jot that down super fast here. All right, looks good. 2 more here, and then we wrap it up. Outside the lines, but on the same side. A lot of teachers don't bring this one up, and I think the reason they don't is because once you take care of all the others, it sort of is just that obvious. Just as an example, if you Google search same side interior, you will get 47 million hits. If you Google search same side exterior, you will get 27 million hits. So it's not that they don't exist, it's just we don't really talk about them much because they're sort of implied by everything else. So if you are not on the interior, you are on the exterior. That would be here and here. So same side would be 1 and 7 and 2 and 8. And then I think you can finish this deal from there. The alternate exterior would be outside the lines and on different sides. So that would be, if you go up here, we want the outside, and then we want alternating sides. So that would be 1 and 8, and 2 and 7. Now, there are a ton of relationships that fit in to these labels. There are a lot of things we're going to learn about these angles, how they fit together, and what the significance of them is. But right now, it's just about practicing the naming and making sure we can identify what's going on. So, thanks for watching. We'll see you next time.